And today, Amresh, we have to identify what is the area as per your need or as per your suggestion that actually we have to include. So I have tried my level best to ensure that those ecosystem products which are frequently used in companies, they are there. So that I have tried from my end. But anyhow, I'll just tell you, once your Hadoop cluster is up, right? As an administrator, what you will be doing is you will be provisioning new nodes, you will be commissioning new nodes, you will be decommissioning some nodes for maintenance purpose, right? And you will be using some monitoring tool in order to always keep a check on the health of your Hadoop, right? You will be doing analytics. You will see that your developers, whatever they are writing, it is getting executed within the expected amount of time, and then you will be probably allocating memory, distributing, you say, various resources to them. Fine. So this is what actually we will be doing as an administrator. But yes, as I told you that a bit of development exposure is also needed. So this is once your Hadoop cluster is set. Now, if you see this particular slide, we call it as Hadoop App Store. Why? Because these ecosystem products are actually going to help us, and you say up in satisfying our needs. For example, if you see HDFS MapRead, these two comes along with our Hadoop installation or Hadoop core download, right? So some of them are there which are important, which I will annotate, and then you will be actually helping us in order to go forward and you say identify some of them which are important, right? So you do have annotation privilege here, which I have given you just now.
Niranjan, for some reason I don't see your screen. I'm not sure if Amresh is able to see. I see a almost like a blank screen here. Sorry to disturb.
I can see.
Amresh, you can see?
I can see.
Okay. Amresh can see in it.
So okay, looks like okay. Okay.
Yeah, because it's important. So now, if you see, are you able to see Vinay now?
No, I just see a blank. That's the light bluish background. I don't see anything. Are you using two monitors? But that's not the problem because if Amresh is able to see, then it should be some on my side. Okay, that's okay.
Okay, but if you are not able to see, then you should. Okay. Okay.
Amresh, are you really able to see? Okay.
I see some icons like iPhone. So.
Okay, I'm just kidding.
Yeah, right. Okay. That's what it's like iPhone only. Okay, so if you see here, these are different ecosystem products, right? Just to tell Vinay, I have displayed a set of utilities
now I see it.
which can be.
Now I see it.
Okay,
good.
Okay, fine. A set of utilities which can be used in order to complement your architecture with Hadoop, right? So Hadoop guarantees you that I'll take care of your data, you need not worry. I'll provide you reliability, you need not worry. If you're interested in using my analytics, fine, go ahead with that. I'm giving you a tool, use Java and write your analytics, right? Now, industry have different various needs, right? That need to be actually countered or that need to be taken care in your big data space, for which you have various products, right? Some of them are important, which I will mark now. If you see here, we have HDFS and MapReduce. These comes along with Apache, so there is no issue with that. Then we have Pig, Hive, and HBase. These three are again very important. Why? Because Pig and Hive provides you analytics capability, and HBase provides you operational analytics, right? Using NoSQL database, right? So you can say I can get operational analytics apart from normal, select-based analytics or data grabbing-based analytics using HBase, right? So I can go and I can add HBase also as part of my ecosystem, right? Then you have various others like Ambari is there, Evro is there for serialization, Cassandra is there, Chukwa is there, Flume is there, HANA. This is actually for SAP systems. Then you have Hyper-T, you have Impala, you have Mahout for you say for runtime workflow management. Then you have Uzi for workflow management again.
Is mod for
It's
machine
machine
learning?
language. Yeah, it's machine. It's machine implement. You can say machine algorithm implementation. I'll be using it.
It's a machine learning.
Yes, it's a machine learning.
AI algorithm.
Yes, so machine learning in the sense you can have your, and you say, as you said, intelligent workflows created using models. So you can say basically use for data scientists or for getting more value from the data. Then you have NAS, which is used internally for search. Then you have Uzi, workflow management. Then you have Scoop, Scribe, Tez, Vertica, Ware, Zookeeper, Horton, Cloudera. These are various ecosystem products. Mapper, EMC, Intel. So if you see, all these are tools which are available. These all are customized Hadoop. All these are customized Hadoop. Pivotal also. Microsoft is also coming. Pentaho, it's becoming popular these days. Then you can go with Jasper. All these, if you see, all these are available ecosystem products. All these are different flavors of Hadoop, which is provided by different companies. Okay, it's clear, right? Not Zookeeper, you start from here. Horton, Cloudera, Mapper, EMC, Intel, IBM, Dell, Teradata, Pivotal, Informatica. Then you have Microsoft, you have Pentaho, you have Jasper. All these are various products which are there, which claims to be powered by Hadoop. Okay, is that clear?
Yeah.
Okay.
Niranjan,
Now,
about this MapReduce and MapR are different, is it? MapReduce, it seems to be a part of Hadoop, right? But MapR is sort of a different flavor of Hadoop, is it?
It's a company. It's a company they have customized, like Cloudera. MapR is another company of Cloudera.
Oh, okay. It is nowhere related to MapReduce, right?
No, they use Hadoop technology, but they have customized it for customers.
Yes, and MapR is a product.
Both use Hadoop. But it's like Linux, different flavor, right? Linux you have, and there are so many distributions for Linux. They have customized for their needs and for enterprise like that. MapR and Cloudera, there are two different flavors of same Hadoop.
Thank you. Got it.
So here is a question.
Yeah.
Good. You're saying something. Hello?
Hello?
You're saying something?
No, Ambrish, this is Vinay. I think looks like
we lost him or something. Hello?
I was saying that in order to give confidence to the client that you need. Hello? Yes, I was saying the same thing.
Yeah, so it's not. It's mostly productionization of Hadoop environment.
No, I'm there.
Hello? I think
Niranjan,
we can't hear you.
We cannot hear you properly. You're getting in and out, Niranjan.
Hello.
Hello, yeah. Niranjan, Vinay here. I think now we can hear you. Hello?
Yeah.
Yeah. You are asking.
I think it's very bad.
Yeah. Amresh, you are asking some question, I feel. Yeah, Amresh, you are asking some question. Yeah, there is just what is the relationship Teradata.
I think looks like the packets are your internet connection somewhere something is wrong. Looks like they're arriving very fast sometimes, so your frequency is changing, tone is changing.
Now, is that fine?
Yeah, it is good now.
Yeah, it's good now.
So what I was talking was that relationship with Teradata, right? Amresh?
Yeah.
Yes. So if you see, you have different ways of managing data, and when it comes to database and technologies which came forward in order to assist database, right?
Yeah.
Teradata has its own capability, right, where you can you might have heard about partitioning of data is what is there in Teradata, right? Capability is there in Teradata. So if you mix capability of Teradata with Hadoop, you really get a very sound system in order to manage and do analytics. So there are actually systems where you'll find that they have advocated on existence of Hadoop with some assisting technologies like Teradata or even you say.
So Teradata uses similar kind of parallel technology. They have different nodes also. And only thing is relational database. It's a complete database, and here Hadoop is a platform, more in an environment. But in Teradata, do they have any connectivity or anything? That was my question.
Yeah, they have connectivity. Okay. They come up with connectors. Hadoop has a connector that helps you to connect to Teradata.
Okay.
That's it.
Because they have their own Astro database they have created for to compete with Netezza. So that's why I was wondering what they are exactly doing.
No, we have connected to Teradata using a connector which actually is specifically written for Teradata and Hadoop.
Okay.
So you have a different actually company which is just focusing on coming up with various Teradata, not Teradata, various connectors which are meant for various ERPs and various data storage mechanisms which are there.
Okay.
It's a big market now.
Yeah, I know that.
Okay, fine. So these are the ecosystem products which we have, and various providers are there. We have to decide why I should go with MapR or why I should go with Pivotal, why I should go with Cloudera. So that has to be studied, and that will be decision which will be taken care by your architect. But yes, it always depends on your existing architecture, and then you have to identify which distribution complements better. You say your existing architecture. So whatever is our existing architecture, you have to go and use that particular Hadoop distribution which actually complements it. For example,
so in fact, sorry to interrupt you. In fact, I am looking for that perspective. Do you have any kind of comparison sheet or anything? Because I'm sure they are in the market, means they must be positioning themselves for certain features or certain criteria.
Yes.
So, is there any comparison between MapR and or any other comparing products?
Yes, like we can do it on Pivotal and Pentaho and then Cloudera, MapR, Hortonworks. All four we can keep together. And architectural point of view, whatever features are required, we will have a comparative study that which one is there in what and how actually it is provided. So then probably it will help us out. Because if you see Pivotal, it is from EMC. So it complements all EMC storage products. Okay. Also, in virtualization, it is better because now EMC has bought VMware.
Yeah.
Right. So there are certain, you say, clustering architectures which works very good when you go with Pivotal, especially if you are using VMware space or VMware clients.
Yeah, but these are infrastructure again. I'm talking about like when you have a structured data and unstructured and semi-structured data. So what kind of flavors? Sometimes you use column-oriented databases also, right? And that also considered to be big data also, or part of big data. I don't want to relate to Hadoop only. Because big data means large volume of data, or maybe like variety of data, that kind of thing. Hadoop is supposed to be a tool or enabler. So even like column-based databases are also there. Databases are also there.
They are there.
Whole thing, when you put in an enterprise, you have to know which one, what point of time, and what type of data you are going to use for an enterprise.
Yes, so we can do a comparative study. For example, if we talk about handling big data, we will first identify what all big data is there, and then, for example, where MongoDB fits better than HBase, or where other NoSQLs are there which fits better than MongoDB. So we can do a comparative study. I'll prepare that document for you, and I'll get back to you.
Okay, sure.
Okay, fine. Now you can pick up any product from here. For example, you have to set up your Hadoop in order to come up with something fruitful that you can do there in terms of managing big data. So if you see, we were trying to install MySQL, right? We were trying to install MySQL. So if you see, there is no problem. I have already done the installation here. And if you see, this was the for you it never worked, but same thing I did. You see, sudo apt-get install MySQL server and MySQL client.
I think MySQL client was not there.
Okay. Okay, so we can try doing that, because if you see, I have tested it. It's the same thing which I did, and now MySQL server is up. Okay, I did it before starting the session, because I thought, let me test what happens. So now I can get into MySQL here. For example, root, and then I can specify that it should be password. Now it is asking me password. I'll write here root. I get this prompt. Now once I get this prompt, it means MySQL is up and it is running. Okay. Now, since this depends on what database you are using, now installation of MySQL may also have different architectures. Like you can have a cluster, right? The overall idea here is to ensure that to whatever database you are able to, or you want to communicate, and you want to bring data from your database to Hadoop, or you want to store data from HDFS to database, right? How actually we can do that? Now certain things are there which will heavily depend on external people. Like you say, if I go with Oracle, or if I try with Oracle RAC, now I need to have a professional who is aware about Oracle RAC, right? He will do the installation for us, and then he will provide us an entry point. At our end, we have to configure an interface between that Oracle installation or Oracle database provider and our Hadoop. This basic objective of Hadoop should be able to pull data from that database so that analytics can be faster. That's what is overall objective. Now you can do it programmatically. You can do it by exporting there in form of a CSV file and then bringing it to your Hadoop layer. All this is possible, right? But there are certain ecosystem products which provides you direct capability of actually minimizing your tasks and automating certain tasks, like import and export, right? For that, you need an ecosystem product. And if you see what is that ecosystem product, it is Scoop. Are you able to see? I've just changed the slide here.
No, Niranjan, I still see the Hadoop App Store.
No, but I have changed my screen now. Amresh, are you able to see Scoop?
Yes.
Okay, so we'll wait for Vinay to get the screen.
Yeah, wait, okay. Now I see the one with MySQL client at the end.
No, still it has to render. Still it has to render.
I think that screen is gone. There's another screen with scoop.
Wow, that's so slow. Now I see a screen which says MySQL at last. Yeah, now I see it. Hello? Hello? Amresh? Niranjan?
I can hear you.
Okay.
Scoop? Did you get Scoop now?
Yes.
Yeah, I'm there.
Now I see. Okay.
Okay. So now if you see, this is what we have to set up. You see, client is there, right? So this client is writing something in order to use your Scoop as an interface between this environment, which is database environment, and your Hadoop cluster, right? If you see RDBMS, NoSQL, enterprise data warehouse, all these are different sources of structural data. Structure may be different, algorithms may be different, the way data is physically and logically organized may be different. But you have to go and you have to bring it in your HDFS layer so that you can do analytics using common analytical tools like Hive, Pig, or conventional MapReduce. Okay?
Yeah, got it. Okay.
Right. Fine. So Scoop is one of them.
Sorry. When you say analytics, are you referring to any kind of traditional analytics tool like Business Objects, Cosmos, or such tools, so that it can connect to the data warehouse, the reporting aspect of data warehouse as well as Hadoop environment?
No, I'm not talking about those tools. Those tools actually are specific to you say a particular architecture or a particular environment. I'm talking about you have to bring data from all these various you said data keepers, or you said structurally aligned data providers like RDBMS, NoSQL, enterprise data warehouse into your Hadoop layer. This is what I'm talking about. Now, once it is there in Hadoop layer, I can use Hive and HBase or Pig in order to go and do analytics.
Okay, I'm talking about this term which you just you said, analytics. Analytics is a very broad topic, and when you say analytics
can be done using Cosmos. Analytics can be done using you say Hive also. When we talk about Cosmos, now Cosmos has storage. It comes along with tools. It comes along with various other ways of doing analytics.
So can we see, I mean, not today or maybe like in one of the classes, can we see like what kind of analytics capabilities it has? I don't want to run at least, I want to just see like what kind of analytics it can do.
Okay, you mean to say on Hadoop what kind of analytics can be done, right?
Right. I mean, is it something like only we are doing like, okay, how many occurrences of words are there, or how many records or forms are there? Is that simple, or it can go into some kind of very, very complex? And because traditional analytics reportings are like mostly drag and drop by business, because business does analytics.
No, it can be done to any extent. If you see here when we say Pig and Hive, right? Whatever data is there, you build up a new data structure using Hive and Pig. They provide you capability of building that particular data structure. Like in Hive, we go and create Hive tables.
Right.
So we can do analytics. You can write entire query, whatever you need. It supports joins, it supports everything.
Then you have to populate those Hive structures and then you have to run analytics on that.
Yes, right. So whatever data you will get from all this, what you will do is you will populate it here in HDFS. Yes, when you are populating it in HDFS, in order to help people who are doing analytics here, there should be logical way of aligning this data so that proper analytics can be done. So there you will decide.
Isn't it same thing we are doing in data?
It's the same thing.
Data. It's a structured data, but I get that. But same that you're hosting the similar kind of schema pattern in the data house also, or maybe enterprise data house semi-normalized form of data you are going to prepare. Generally reporting tools can be run.
Yes. We are doing the same thing there, but benefit that you are getting here is your data once it's the speed. It's the throughput that you are getting.
Well, parallelism can be achieved through data or
yes, but you think of the cost, right?
This is cheaper. Okay.
The cost will be too less when you go with this architecture because you can use commodity hardware.
Cost is less plus unstructured data also you can handle.
Yes, unstructured data also you can handle. Cost is less, and you can say that load on your data layer will reduce, at least for certain classified analysis that you want to do. Right. That's what is overall objective.
And exactly, I want to know what is that classified analytics you want to do, or be capable of, because we can unload those kind of capabilities from our traditional data house reporting.
Yeah, we can. I'll be taking up certain case studies where you come. For example, whether recording or whether you say analytics, right?
Mm-hmm.
Which will be done sometimes using too old data as well. So what we can do is that part of analytics we can do it in HADOOP because we will keep on streaming data whatever is there here, and we will ensure that if volume of data is too huge, we'll archive it and we will bring it to our HADOOP layer and let client do analysis on whether information or whatever is there on that instead of directly making them connect to existing data warehouse or existing systems. So there are certain things where you feel that huge amount of data is there. Yes, if I go and increment or if I go and increase architecturally my data layer by adding more nodes to it, or as you said by partitioning, or as you said by increasing parallel disk, yes, we can do there also. The problem is cost that we have to manage will be huge.
Okay.
So normally what we do, we keep our data, we keep our architecture as it is. Let it do.
Mm-hmm. So one more
data is there. We have to.
I know we don't. I don't want to jump to them right now, but at least do you have an idea what kind of projects or what kind of case study you're talking about? I mean, do you have an outline of that? Like what you're trying to do?
Yes. See, there are various case studies from each domain. Actually, we can pick up. Let me pick up a simple one. See, nowadays users visiting to website, right? It has become very important. And everyone wants actually to capture the activity which user has been doing or has done on the website. For example, they want to capture and log each and every click also so that they can do analytics later that what all are the pages where clients are there for longer period of time, right? What all pages are there or what all clicks are there which are very frequently done. In this way, we can do analytics to find out that what actually is driving traffic to my site. So we call it as web logs, web hit logs.
Okay, so this was traditionally 10 years back, maybe they were calling it clickstream reporting. Website clickstream.
Yes, clickstream. So now it can be used in better way by using HADOOP because you need not sacrifice data in case if volume goes too high.
Okay.
You can keep it always there because it takes less amount of investment in order to archive that data.
I'll give you an example for Semantic Corporation.
Yeah.
I built that clickstream data warehouse in 2002 or 2003 timeframe. So there we had this website log, web logs and all. We put a star schema on that and we tried to create a data warehouse and analytics for the marketing department. The problem was we could not pinpoint the customer, or we could not match the customer because there's no way we can link them. So you can get a lot of this kind of trails or this kind of log file, but you can get all these counts, but how can you match the actual customer? That is a task, difficult task.
Yes, that is difficult task. For that, see, until and unless you don't identify the customer by at least capturing his session ID, it means you will be able to get the actual. You can divide your analytics in two ways. One is generic, and second one is specific. That's
right.
Where we have a customer who has logged in. So once he logs in, we get information because that session will start now, and we'll have the session ID in order to capture all activities that he is doing.
Right, but generic website you don't have the login, right? So then
we don't have the login, but
MAC address only we got only the MAC address, but from MAC address we cannot derive a customer.
Yes, we cannot derive a customer. This is the reason why, there are two types of customers based now. One is customers who are just visiting. We call them as normal visitors. And second, if a person shares his email ID or something, we can have application developers kickstart a session using that email ID and then capture all the activities that he is doing.
Right.
So we need to have some way in order to ensure that at least we are able to get some ID which can be associated with a customer.
Okay.
And this is what analytics we have to do. Fine.
Okay.
Right. So that is something which depends on domains also, and it depends on actually capability of investment that can be made on existing architecture, and when actually it is moving beyond that. And what is the relevance of data? When it comes to age of data, what is the relevance? Shall we throw it out and still it is important? If it is important, is it critically important for carrying out the operation, or it is critically important for doing analytics in order to understand behavior of, customer or product or anything depending on the services that is being provided by your domain.
Right.
Right. So we have to see and identify it in that way. Right. So this is what is one of the products. It works as an interface between Hadoop and your data store, specifically RDBMS. Okay. It means Scoop has been written keeping in mind RDBMS, and it is written in Java again. Right.
Okay.
So once we have a database, what we can do is we can go and we can try downloading Scoop. Now, one thing we have to always remember: whatever is your version of Hadoop, you have to always ensure that when you are downloading any ecosystem product, for example, if you are downloading Scoop, or if you are downloading Pig, or if you are downloading Hive, you need to ensure that your version of Hive, Pig, or Scoop is compatible with the existing Hadoop version. Okay, so if you see here, this is what is Scoop. You have different Scoop bin for different versions, right? You are able to see my desktop, right, where I am pointing to different versions of Scoop. And if you see,
yes.
So here you have Scoop 1.4.4 bin for Hadoop 1.0.0. Right. So this is what is the Hadoop which I'll be using now, and later when we move to Hadoop 2.0, where we will do installation and we'll see the difference, we will be downloading this Scoop. Right. So we have to download this Scoop. We have now database installed, or if not installed, you need to have certain details about your database, like what is the IP address where database is there, what is the username, password, right? And since I told you that Scoop works on principle of JDBC, that is Java, you have to provide it the essential connector component so that it can go ahead and try connecting to the database on basis of inputs that you are going to get. Okay, so I'll just go to my downloads where I have downloaded this. Installation of any ecosystem product is very simple. You can just go and just copy it because I want to keep everything in home, and I'll paste it somewhere here. And then like installation is nothing but just extract it. This is what is you say simplicity which is there in installation of especially Java based frameworks. You have to just extract and you have to set the environmental variables in order to ensure that it is done. Right, so we have scoop here. Its name we can go and we can actually rename it. I don't want all these lengthy names here. I can just go and take scoop. Now once I open scoop, you will find scoop has its own conf, bin, right, and lib. If I open lib, you will find all connectors which comes pre-distributed with scoop, like HSQLDB. Now this is again a database, in-memory database, whose driver comes pre-distributed. Right? Now we have to decide if we have to connect to Oracle, or we have to connect to MySQL, or we have to connect to MS SQL Server. We need to have that connector available. If connector is not there, our scoop cannot communicate with that particular database. Right? So for that, what we have to do is we have to just go and download the right connector. So I'll just go here, do google.com, and depending on your database, because most of the drivers are freely available if you want to connect it using Java based framework. So you can say scoop is nothing but it's a framework that provides capability of working as an interface between your Hadoop cluster and your RDBMS. Right? So this is what is the framework. What I'll do, I'll just go here and I'll write download MySQL Java connector, because MySQL will not only provide you connector for Java, it will provide you connector for you say .NET as well, right? So I'll go to the right place because I know scoop is written in Java. I can go and select platform. I'll go with platform independent. It works with all versions, and then I'll go and I will download. I'll just go and download. I'll download zip one. You can download star also, it depends. No thanks, just start my download. I'll save it. Click OK. Now if you see, we will have here MySQL download ready. Now this is connector, which will be used as a driver which will intercept all your SQL calls and it will communicate with MySQL server. That's what is overall responsibility. I'll go to downloads. I have now MySQL connector downloaded. I just take here and I can extract here itself. You can extract wherever you want. Now you have here the connector, and this is what is the jar. I have to make this jar file available. What I need to do is I'll copy this. I'll go to my home in which I have scoop. In scoop I have lib. I have to just make this connector available. Now you have to do same task whether you are going with Oracle or you are going with MySQL or you are going with any database. You are going with Informatica. You are going with any system which understands you say SQL 92 or ANSI SQL standards. It's clear, right?
Yeah.
Okay, fine. So now after doing this, your system is ready to get connected to MySQL. Now I'll take you to bin. So in bin, if you see, you have one important script which actually starts up your scoop. Like you have Hadoop there, you have start all there. Similarly here also you will have various. And if you see here, commands, just focus on this. Scoop import all tables, scoop list database, scoop list tables. Now all these are small scripts that are written and they are provided to you, right? So if you open this, you'll find here it will execute. Actually I have to open with.
So basically, these are like it will give more information about the connected database actually. So what are the databases are there? What are other, like any catalog information or something like that?
Yes. Yeah, these are the commands which are already written, which you can actually use in order to. I'll just show you one so you will understand. I feel once I open that. These are nothing but they are scripts.
Yeah.
Right. If you see here, this is a script which is written. Scoop list all databases.
So that must
So
be
we have to go and yes. So we have to go and we have to see. It will be a program which will be written in order to get it. Similarly, you can configure your scoop. For example, if you see we spoke about core site.xml, map-read site.xml and all. Similarly, you will have scoop site.xml also in order to configure your scoop. I'll just go open with gedit and you see.
Right.
Right. So here, set the value of this. Right. And here you can see scoop connection factory. Are you able to see here? So you can customize your scoop as per your need. Right. So this itself is a product. What you are doing is you are using this product in order to go and build Hadoop as per you say scoop as per your need. For example, you see JDBC HSQL DB5 temp. So this property is already enabled, right? Now if I want to add my property for my database, I can go and add it here itself, right? So these are some of the files which we'll look into once you download it. You know, join that lady session now and we wait 10 minutes. You should now. Okay, so these are the things actually which we have to keep in mind. Now, you have here docs, which provides you API and all, which you can definitely go through. Developer's guide is there. You can customize this scoop as per your need, right? But whenever you are working with it, please ensure that these ZAR files are there, okay? Because these ZAR files will be used when you go and configure your Hadoop to work with scoop. Is that clear?
Yeah.
Okay, so you can use anything in order to actually, any database in order to enable your scoop to do that, right? I don't have, you say Hadoop installed on my system as of now, right? But what I will do is, I'll go to scoop bin and at least you will come to know, I'll just quit here. You'll come to know what actually environmental variables are required in order to work with scoop. Fine, so I'll go here, cd scoop, cd bin, and I'll write a /scoop. Now you see it will start shouting on me. It is saying user lib Hadoop does not exist. So what it is looking for?
Hadoop.
Yes, it is looking for Hadoop common core. So let me go. I have not yet configured because you know my system was crashed. So but anyway, I'll just go and I have downloaded Hadoop here. I will just go and I will copy it here in home. If not, I'll just go and do that. Okay, but you understand, right? Because I don't want to do as of now here. I just wanted you to know.
Yeah. So this is the question. When let's go to the diagram which you just shared.
Yeah.
Overall architecture diagram.
You got it?
Yeah. Yeah. So this one.
Yeah.
So scoop is connected to Hadoop. Is this connected to the name node or the data node?
Yes, good question now. Yeah. Now scoop is connected to Hadoop and now you see scoop itself will launch a map reduce. For example, if I said I want to import all tables which are there in database to HDF, right? Now scoop is a framework which has been provided to us. But internally what it does, it runs Java program. So it creates a job and that job runs a code. That code is written in JDBC which will connect to database, get all data and then use MapReduce in order to write it on the HDFS.
Right.
Okay. So here scoop need not be there on your you say on the name node or somewhere, right? Scoop can be externalized. It can be present wherever you want. You have to just tell that please use this particular name node in order to process the job. So you have to basically provide job trackers UI.
Yeah. So the reference to the name node, but Scoop can be in a different machine altogether, or within the.
It can be there in a different. It can be there in a different.
But the interaction has to happen through the name node.
Yes.
Okay.
It has to happen through name node because name node takes care of everything, right?
Okay. Yeah.
Okay. Is that fine?
Yes.
Yes. So when we are loading the data, suppose Scoop is running, and we have a huge volume of incoming traffic or incoming data is there, and it is interacting with the name node. Is it Scoop is going to parallelize the loading process, or is Hadoop is going to take care of it?
It is Hadoop is going to take care. Scoop is just an interface between your RDBMS and your Hadoop cluster.
Okay.
It just takes responsibility of bringing data from RDBMS to Hadoop and Hadoop to RDBMS.
Okay.
That's what is responsibility. Okay. Is that fine?
Yeah. So suppose Scoop. I don't know whether we are going to cover it, but right now I have that question. Suppose I have multiple sources where I'm collecting data, and one is a RDBMS, suppose, another is suppose, like you said, like from a website I'm getting from Clickstream or something of web hits, whatever hits I'm getting. So that could be a kind of log. So can it at one time perform 2-3 different sources, or can it handle 2-3 different sources?
Yes, it can.
Type of data also.
It can.
And when it goes to the name node, and I'm sure name node somewhere, I'm just thinking that it must be accumulating the data in one.
No. Name node will just tell that what all data nodes are available for storing that particular data.
No, but so suppose it's a big file. I got in a OS level something like a big file, and it's in my laptop, whatever you see here right now. Okay.
Yeah.
Or some other machine which is something like the file is there, and I'm asking Scoop to take that file and put it in Hadoop environment.
Scoop will only work with RDBMS.
Oh, okay. It's only for RDBMS.
Yes. For rest of them, you will have different other ecosystem products. Like Flume is there for log analysis and all. So I'll be covering all that.
Okay. So if I'm copying, suppose forget Scoop, somewhere another Linux machine is there, and I just use. Remember, we had some utility to get into the system and get out of the system. And I stored one large chunk of file. And if I'm looking at the name node, the same file is going to be there, but in data node, those files will be distributed, which is transparent to the person who is working on the name node, right?
Yes.
So I'll still see one file, but internally it will be distributed already. Or so do I have to provide some special commands? Okay, now you distribute it, or something like that.
No, you need not. Because that behavior is automated and it is part of Hadoop cluster. Okay. As a client, you will just go and request Hadoop cluster to store that. Now, it is Hadoop cluster's responsibility to see that amount of data and then split it into a number of chunks, maintain metadata in name node, and ensure that whenever client is asking back that file, your name node is able to initiate a job which goes to the required data node, collects the data which it has split, and then creates it and give it to the client. Okay,
so I'll give one simple example now. Suppose I have like some records are there, so number of lines, like 10,000 lines are there. And I just put that file, I just copy that file in the name node environment.
You say SDFS.
So, SDFS. In SDFS, I copied that file. Now I'm going to run some program written in Java, written in some scripting language or anything.
Do and okay.
So I will write that program to just count the number of records. Okay.
Yeah.
So that particular program will be running in HDFS or outside HDFS. I don't know that we can find it.
No, it will run in the job tracker and the task tracker. The responsibility of running the job is of job tracker and task tracker.
Okay,
Yes, benefit of task tracker is that it is in the same node where your data node is.
Okay. So that means job tracker, I have to have some kind of some way the job tracker has to run that, and then job tracker will is going to run that parallel divided into the task and then
Yes.
Okay.
Yes, that is how it is.
And then this particular, suppose if I write any Java program, is it going to run an HDFS environment or is it going to run in Linux environment?
It is going to run in HDFS environment because MapReduce, right? It will be job and it will be task. So it will run in HDFS environment. Not in your
job tracker. So job tracker is using HDFS. So
yes. Yes.
Just I want to position different components.
Yeah, sure. So till here is that fine?
Yeah, please go ahead.